Let's start with integers. We'll create a simple variable. Let's say we create variable a and we'll assign any numeric value to this. It could be, let's say, 101. Now, an integer value in Python can take a number of any size. Now, since we already discussed, whenever there is scope for an integer overflow, Python automatically typecasts an integer to long and increases the precision. So we don't really need to bother about int and long. We can just go on typing a large number into any variable, and the entire process of typecasting it and allocating more memory happens internally. Now, the way I would execute this command, this being a Windows system, would be I would select or highlight the command and I would press Control and Enter. This would be different in the Mac or Linux system. In Mac, it would be Command Enter, and in Linux, probably it might be Control Enter, similar to Windows. I would leave this to you, just a reader, to figure it out. For Windows users, you can choose Control Enter to highlight and execute the command, or you can also type in the command into the console and execute it. Now, to check the type of the data or the data type, Python actually provides a command called type. So if I say type of A and if I execute this command with Control Enter, we can see that data type is int. This would have already been visible with the variable explorer also. So there's a variable name called A, the type is integer, the size is 1, and the value is 101. What we need to bother is probably the value, the name, and in some cases, the type. You can also do a lot of mathematical operations on the data. So let's say, like any other language, you would want to execute some mathematical operations like addition, subtraction. It's very straightforward and similar to what you have learned in the past. So I would say, let's say a is equal to a plus 6. And if I want to execute this, I can see the new value is now updated, 107. I can verify that with a print command. So let's type a print command as a print of a, and you can check the value here. So the value is 107. If you want to check the type of a, again, that would be int. Similarly, you'll have additional mathematical operations. Let's say something like a is equal to a minus 8, or let's say take a larger number, a minus 89. That gives a negative number. Oh, sorry, since this is a large number, let's say 890. Now we should definitely have a negative number. I can do a print of a, the value is minus 872. Type of a, it's still an integer number. Now, there are scenarios where a number is typecasted to another data type to avoid precision loss. So, for example, we would go ahead with a division operation. So, a is equal to 87 divided by 12. Now, the resultant number will actually be a decimal number. So to avoid, so had this been just an integer number and it was supposed to remain an integer number after the execution also, there would have been some sort of loss in the precision. So to avoid that, to avoid information loss and precision loss, Python would typecast it automatically to float. So if I execute this number, you can see that the data type changes, the value is 7.25 and the type is float. This would be the same if we had something like let's see, we again have a is equal to 101. Now a is integer, and I will say a is equal to a divided by 12. Now the assumption would be a is integer, like we see over here, and the resultant a after the execution also should be integer, but that won't be the case. So since we divide 101 by 12, we would actually typecast that to a float number. There you go. You can see the type has changed, float, and we have the new value stored over here. Now we've covered integers, we've kind of covered float, and the kind of arithmetic operations that's possible with integers are also possible with the same data type float. Probably all of them, which falls under the Bodmer's rule. Let's look into a very simple data type called Boolean. A Boolean is a data type which actually stores value of true and false. Now in Python, instead of using the values 1 and 0 for flag, you can actually use the value true or the value false inside a variable. Now, if you create a Boolean variable with a Boolean value, let's say flag is equal to bool, and we execute this command. By default, we'll have the value false stored in it. In some cases, when you override the value, you can actually say flag is equal to true, and we'll have the new value coming up over here. And this data type remains bool. Boolean is actually a very handy data type in cases of conditional statement execution. So when an if clause or a while clause, you have to check a condition. Boolean variables, since they have the values only as true or false, becomes extremely handy to check and proceed. Next is another popular data type called strings. So character arrays or strings are the most popular way to store text variables. So I'll say A is equal to my name is XYZ. And if I store this and execute this, you can now see that the data type is str, which stands for string, and we have a string value over here. We can do some string related operations over here. Now, Python provides a rich set of set of functions associated with the string variable. So for example, let's say you wanted to reverse a string, you want to capitalize a string, you want to slice a string, or you would like to, let's say, uh, check for some substring positions. All of those functions are already made in string. We can actually, we'll look into this later. I'll just show you an example. Now, since this is Spider, you'll actually get autocomplete and function lookup also. So since A is a string, let's say I execute this and A is a string, and I would say A dot, the kind of functions associated with the string comes up. So we have an exhaustive list of handy functions for string operations over here. So probably anything you would have already used with strings in something like Excel or R or something like Java or C++, all of them have been neatly added into this exhaustive library. So let's say had this value been my name is XYZ with a small m, and we need to capitalize this letter, so we can use something like a dot and say capitalize. We call this function. We can see the value will have been updated. Oh, my apologies. We would say a dot is title, or let's say if we create title. Yes, title. So this would actually capitalize the first letter of a sentence. As we see over here, my name is Khan. Sorry, my name is XYZ. My bad. Alright. And then we have a list of other commands like a dot strip, split lines, start split. So all of these functions we'll be using in a while we do data engineering and data manipulation. So all of these functions actually come in handy. So is alphanumeric, is alpha, is decimal, is digit. These are functions which are used very frequently, and then we do slicing and dicing across strings. All these functions are very handy while we do string-related operations and data manipulation in the upcoming sessions. Another way to concatenate a string would be, I would say, let's say you have a new string called B, and you want to concatenate A with the new variable or the new value. I would say just a random sentence, please ignore the grammatical syntaxes. Yes, so you can see that the new value is now, my name is XYZ, without a space, and I am cool. This is how you can concatenate two different strings. If you want to make it more neater, I'll just say concatenate a space and then this one and then go on as long as you want, and this gets a little neater. So that's strings. We've just seen a sneak peek into the data type. There are several other possibilities and functions that we can play around with the string data type.